9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. And liftoff. Go Falcon, go BlueBird. Vehicle is pitching downrange. M1D chamber pressures are nominal.
At T plus 30 seconds into flight, Falcon 9 has successfully lifted off from Space Launch Complex 40 at Cape Canaveral Space Force Station in Florida. We're currently throttling down to prepare for max Q, which is the point of maximum aerodynamic stress on the vehicle. Max Q
and telemetry nominal.
Max Q occurs in the lower atmosphere, where there's still enough air to create significant resistance against the rocket. This is when the pressure pushing against the rocket is at its highest point, and it's
Vehicle is supersonic.
And it's a key test of the vehicle's structural integrity. After max Q, the rocket continues to accelerate, but the air becomes thinner, reducing the stress on the vehicle as it climbs through the upper layers of the atmosphere.
Max Q.
And there's the call out for max Q. Merlin engines are back at full power now that we're out of the throttle bucket. And from here on, even though velocity is rapidly increasing, the atmospheric density is decreasing, resulting in less loads on Falcon 9. Now we have several events coming up in quick succession, starting with MECO, followed by stage separation, and second engine start, or SES-1. Main engine cutoff, or MECO, is where all 9 Merlin 1D engines shut down to slow the vehicle down in preparation for stage separation, where the first stage separates from the second stage. Then the MVAC engine on the second stage will light, which is called out as second engine start 1, or SES-1. This engine burn, lasting several minutes, will propel the second stage and our payloads to orbit. After that, the fairing will jettison from the second stage, as it's no longer needed to protect the payloads once we're in space. We should be hearing the first of these callouts in just about 10 seconds from now.
Main engine cutoff.
Stage separation confirmed.
MVAC startup.
And we had confirmation of those 3 events that happened back to back: main engine cutoff, stage separation, and second engine start 1. Coming up next will be fairing separation. Again, we jettison the payload fairing halves now that they're no longer needed in the vacuum of space, and will attempt to retrieve them once they fall back to Earth.
Fairing separation confirmed.
And there we just heard confirmation of fairing separation. They'll make their way back to Earth for recovery. Now, the next major milestone coming up is the entry burn on our Falcon 9 first stage, which is scheduled to occur at the T plus 6 minute and 25 second mark. The entry burn is used to slow the first stage as it heads towards our drone ship, a shortfall of gravitas, located in the Atlantic Ocean. The booster engine graphic on the lower left-hand corner of the screen displays the arrangement of the 9 M1D engines, with the outer ring of 8 and the center 9th engine. And these are held in place on the vehicle by a structure called the octaweb. The entry burn is similar to pumping the brakes to slow down the vehicle as it passes back into the Earth's atmosphere. And we need to slow down to reduce re-entry forces, which then helps us recover and reuse the first stage. Then, shortly after entry burn, the booster will initiate the landing burn, which will slow the vehicle down before touching down on our drone ship. We're still more than a minute away from the beginning of the entry burn. So that first stage is not only using the Merlin engines for the re-entry and landing process, it also uses its titanium grid fins and nitrogen gas thrusters for stability and control. While views aren't the greatest right now, from time to time you might spot those white puffs coming from Falcon 9, and those are the cold nitrogen gas bursts, which help with attitude control. So we're still coming up on the entry burn. We should expect that within the next 20 seconds.
Stage 1 FTS is safe.
Stage 1 entry burn startup.
And there's the call out for the entry burn startup on the Falcon 9 first stage. This burn will last about 25 seconds and again is slowing the vehicle down in preparation for its final burn and landing.
Stage 1 entry burn shutdown.
And that concludes the booster's entry burn. And as mentioned earlier, we will be attempting to recover this booster with our drone ship, a Shortfall of Gravitas, currently stationed in the Atlantic Ocean. And now the next milestone, coming up in about a minute, will be the Stage 1 landing burn. You can follow along with the burn via the engine graphic at the bottom left of your screen. And as the burn happens, you'll notice a drastic decrease in the speed and altitude of the vehicle. Coming up shortly, we'll have the start of the landing burn for the first stage.
Stage 1 transonic.
The landing burn is the final burn of the Falcon 9 booster, used to reduce the remaining speed of the vehicle for a gentle and precise landing.
Stage 2 terminal guidance.
And as Falcon 9 descends towards the drone ship, keep an eye out for the first stage landing leg deploy just prior to touching down.
Stage 2 FTS is safe.
Stage 1 landing burn.
There's the call out for the landing burn startup on the Falcon 9 first stage. Again, this is the final burn that this booster will execute leading up to landing.
Stage 1 landing leg deploy.
MVAC shutdown.
Stage 1 landing confirmed.
As you saw and heard, that was a successful
Nominal orbit insertion.
first stage landing of our Falcon 9 booster. As a reminder, this booster flew for its 29th time. And now while the booster has completed its part of the mission, our first of 3 payload deployments is expected at T+53 minutes. And before that, the MVAC engine on the second stage will execute a second burn